Hey everybody, and welcome back to my YouTube channel, HansenMath. Today's lesson is on something called the law of sines. Before we get into it, a couple pieces of background information. Regardless of what kind of calculator you use, it could be graphing like I have here. I'm going to hit mode, or it could be scientific, or it could be cell phone. You have to make sure you're in degrees. If you're in a mode called radian, you're going to get all of your calculations wrong. So you want to make sure you're in degree. My second disclaimer is that this lesson is based on a working knowledge of the right triangle trig functions, sine, cosine, and tangent. If you don't feel you have a competency with those subjects, then you should go back to one of my prior videos. So getting right into the meat and potatoes of this lesson, the law of sines was developed for working with oblique triangles, which means that the triangle has no right angle. So if you look at this triangle, you can see that I have 98 degrees on angle B, 45 degrees on angle A, and 37 degrees on angle C. There is no right angle. So you might say, well, Mr. Hansen, you swore to me that you can't do sine, cosine, and tangent unless you have a 90-degree angle. And I'll show you where this is all coming from at the end of the lesson. I'll do an informal proof on how this formula was derived. But suffice to say that the law of sines is designed to work for oblique triangles, no right angle. So this will be another tool in your toolbox. And it works by proportional reasoning, which let me show you here. It works by a comparison of a side compared to the sine of the angle opposite. So if we look at A here, which is 20, its opposite angle is 45 degrees. Okay, so I could write a ratio of 20, which is the side length of little a, compares with the sine of 45 degrees. Little a is a side length opposite from angle capital A. Okay, now that has to be equal or proportional to the next ratio, which would be side little b, which I'm attempting to show you as soon as I can get out my eraser here. Okay, side little b is right here, and it is opposite or across from angle capital B. So I can have the following relationship. I can say that this length of 28, which is little b, compares with the sine of its opposite angle, which is 98 degrees. Okay, I hope I'm showing you a good job of how the angle is related to the side that's opposite or across from it. You should have studied this in geometry. All right, and then finally, we have our third angle side pair, which would be related by C, which I have put in green. And we have side C, which is a length of 17. That's a ratio of 17 to sine of its angle that is opposite or across away from it, which in this case is angle capital C, which is 37 degrees. So we have that. Okay, so you can see that I have the opposites in red, I have the opposites in green, and I have the opposites in blue. Now, how this works is the following, and I will admit there's a little bit of a fudge factor here due to wanting to avoid decimals. If you take your calculator and you press 20 divided by sine 45, okay, and without rounding, let's just say we have 28.2. So I'm going to write that down. That's 28.2. And next, we are going to do 28 divided by sine 98. 28 divided by sine 98 gives you 28.2 again. So I'll write that down, 28.2. And you can have one guess what you think the third fraction converted to a decimal will be. This will be, 17 divided by sine 37 degrees is 28.2. All right, so there you have it. These are all proportional. They have to be, or else this law of sines would not work. Okay, but the biggest thing to remember here is when you establish these ratios or fractions, it has to be the side length compared to the sine of the angle across from it, so on and so forth. All right, so there is a little background. Now let's get into a couple of working examples. So let me move my paper and we'll get right to it. Okay, in example 1 as pictured here, you see another oblique triangle, no right angle. And the first thing I want to do is I want to do a little bit of setup. So here I can see I'm just randomly picking a place to start. I can see I have angle C here, and angle C is across from side C, so that's labeled and that's good. Side C is unknown in length, but we'll find it. Okay, next I will grab angle B. Angle B has to be opposite side B, so I'm going to label this 7 little side B. All right, so we've got that. And then finally here, last but not least, we have angle A, which has to be across from or opposite little side A, which I will mark. All right, so I would consider that the opening steps here. I want to see 3 little ABCs for the sides and the corresponding capital ABCs for the angle. All right. After I do that, the next thing I would explore is I would see what scenario we were given. Here we have 2 angles and a side, an angle, and a side. So if I have 2 angles, I love that because I know I can find the third angle due to the triangle interior sum being 180 degrees. So without skipping a beat, I am going to go over to my trusty calculator and I'm going to plug in the triangle angle sum of 180. I'm going to subtract away this 35-degree angle, and I'm going to subtract away this 105-degree angle. And what's left will be angle A, which is 40 degrees. So I will put that into the picture. All right, 40 degrees goes right here. So if you're told to solve the triangle, which is what we're going to do here, solving the triangle means that you find all 3 angles and all 3 sides. So the good news here is the angles are already taken care of. Boom, boom, boom. All 3 angles are done. So now we are going to work on the sides. How do you do that? You use the law of sines, proportional reasoning. So let's take a look at what we were given. I have side A is unknown, so I don't want to start with that. Side B is known, and so is capital B, the angle across from it. So I always want to start with the known ratio. So I'm going to write down on my paper, I know that I have side B, which is 7, and that's going to compare to the sine of the angle opposite that, which would be capital B, which is 35. So that is my first ratio. Now I'm going to set that equal to another ratio where one thing will be known and one thing will be unknown. So how about let's attempt to find, let's find side A. So side A is little a here, and it is opposite capital A, which is 40 degrees. So that's the sine of 40 degrees. So that's your setup using proportional reasoning. Now, how do you solve a proportion? My favorite technique from middle school was to do a cross product or cross multiply. So we're going to multiply in the direction of the variable first, which would be this way. So we literally have length A times sine 35, which would be A sine 35. And that's going to equal the other cross product, which would be multiplying this way, which is literally 7 times, I can make my 7 better, 7 times sine 40. Okay. Next step is to get A by itself. So A is multiplying by sine 35. To undo multiplying, you divide. So you divide whatever you do to one side, you do to the other, divide both sides by sine 35. What happens next is anything divided by itself cancels to 1. So here we have 1 times a is a equals, this is our answer. I'm going to pop the whole thing into the calculator in one fell swoop like the following. I'm going to press 7 sine 40, close the parentheses, divided by sine 35. Bam! 7.844. That's an irrational number. It goes on forever. So I'm going to choose to round to the 10th place, which is one decimal, one number past the decimal point. So we'll call that 7.8. Okay. So now length little a is not unknown. It is worth 7.8. So I'll put that into the picture. So now if we're working on this, we know little side b is 7 in length. Little side a is 7.8 in length. So now we just need to find little side c. Well, we will also do that again with this law of sines. So let's start with our original known. Let's start with our original known ratio, which was this. So we're going to start with 7 over sine 35, okay? And again, that was b over sine capital B. And we're going to set it equal to, well, what do we need? We need c here. Side c compares to the sine of its opposite angle, which is 105 degrees. All right? So that is a competently set up proportion. So we will do cross products. So we're going to multiply in the direction of the variable. C times sine 35 is C times sine 35 equals the other cross product, which is multiplying this way, which is 7 times sine 105. Now, we want to get C by itself. So to get C by itself, we do the inverse operation. So to undo multiplying by sine 35, we're going to divide both sides by sine 35. Whatever you do to one side, you do to the other. And we'll simplify a little bit here. Anything divided by itself cancels to 1. So we have our 1c, which is the goal, equals, and I'm going to pop this whole expression into the calculator to get a final value. So if I go over to my calculator, I have 7 sine 105, close the parenthesis, divided by sine 35. Boom, 11.78, which rounds to 11.7. So C is 11.7, 11.8. Please forgive me, 11.8 is the length. Okay, rounded to the nearest tenth. So C is 11.8. So let's double check and let's see if we have indeed solved the triangle. We have 1 angle, 2 angle, 3 angles, and we have side A length, B length, C length. Boom, done. All solved with a little bit of geometry and the law of sines. Okay, that was example 1. There is a second example here to the right. So if you need to take a look at this a little bit further, you might want to hit pause. Otherwise, I am going to clear this right now so I have some room to write, and we'll move on to example 2. All right, in example 2, I want to start from scratch and do the same type of reasoning, okay? Here is, well, let's see what we have here. We have only one angle. That's kind of a bummer because if we have only one angle, we can't use simple geometry to figure out these two, okay? So that's kind of sad. So this one's a little bit different. In this example, we were given 2 side lengths and an angle. All right, so this changes, it doesn't change our setup, but it changes some of the math, so hang tight. So with that in mind, let's diagram this sucker. We have angle A, which will be opposite from side lowercase a, okay, so we've got that. We also have angle C, which is opposite side C. So I'm going to put a little C here, okay? And we have angle B, which is opposite from side B. So I'm just going to label this 4.7 side B. So now I have all my labels, and let me erase just a little bit so it's not so cluttered. So we have our lowercase sides ABC and our uppercase angles ABC. Okay, all is well. So let's start with writing out a ratio of known quantities. So let's see what we have. Capital A and little a are both unknown, so we can't start there. Little b is 4.7, but capital B is unknown. We can't start there. So we have to start here with little c and big C. So we know 5.5 compares to sine of its opposite angle, which is 63 degrees. Okay, get it? That is a known relationship of side compared to the sine of its opposite angle. All right, so let me make that look a little bit better. Now, we can set that equal to something to find a missing quantity now. So how about we attack angle B? Angle B is opposite side B. So side B is 4.7. We put the length on top and the sine of its opposite angle, which would be sine of capital B on the bottom. Now, wait a second, Mr. Hansen, we didn't have an unknown angle in the first problem. That's correct, because we were able to figure out the angles right off the bat. Now we cannot, because there's two unknown angles. So we're going to have to use law of sines to find the unknown angle. It works out just great. Hang with me. So now we have our proportion, and we're going to cross multiply. I always start with the direction of the unknown. So I have 5.5 times sine B, which is exactly that, 5.5 times sine B, equal to the other cross product, which would be 4.7 times sine 63, which I will write down as 4.7 times sine 63. All right, so now what's next? We want B by itself. B is attached to sine, so I'm going to divide both sides by 5.5. Okay, how does that help? 5.5 divided by itself will cancel, leaving us with sine of capital angle B equals. Now I'm going to take all this stuff and I'm going to press this expression into the calculator to get a simplified value. So going over to the old trusty calculator, we have 4.7 times sine 63, close the parentheses, divided by 5.5. What do we get? 0.761. So I'm going to write that down. We have 0.761. Okay. Now, how do you get an angle by itself? You have to do some inverse trig. So to get B by itself, we have to take the inverse sine of 0.761. So on my calculator, I'm going to hit second or inverse second sine of 0.761, and we will get 49.55 degrees, which I will round to angle B. If I can get my pen to work, angle B is worth 49.6 degrees. Okay, if the rounding throws you off, don't worry about it. This is the important thing right here, that you're getting the math right. Okay, so it's approximately 49.6 rounded to the 10th degrees. So now I'm going to add that into our picture. B is now known forever. For the rest of this example, B will be worth, let me put it here in black pen, B will be worth, oh my goodness, B will be worth 49.6 degrees. Can you guys pick up the good news here? Once you have two of the angles in a triangle, you can find the third by subtracting from 180. So if I go over here to the trusty calculator, if we do 180 minus 63, which is angle C, minus 49.6, which is what we just found for angle B, we are left with 67.4, which is angle A. So I can write angle A is worth 67.4 degrees. So now the three angles are solved. They're all set. We have side C length, side B length. Now we need to find the length of little side A. So to do that, we will do one more law of sines, and then this will be wrapped up. So what do we have here? We're trying to find side A, right, my friends? So side A compares to the sine of the angle opposite it, which would be capital A, which is now we know 67.4, and that must equal, let's go back to this relationship because it was true, 5.5, which was small c, must compare to the sine of large C, which is 63, cross multiply. So we've got A times sine 63 would be A sine 63. That will equal this cross product, which is sine 67.4 times 5.5, which is 5.5 times sine 67.4. Okay, how do you get A by itself? To undo A times sine 63, you divide both sides by sine 63. Whatever you do to one side, you do to the other. That was sine 63. And now these will cancel to 1, so we're left with 1A equals whatever all this simplifies to. So back to the trusty calculator, we've got 5.5 sine 67.4, close the parentheses, divided by sine 63, enter, 5.69, which to the tenths will round to 5.7. So that is our A length, 5.7, which I will put into the picture. A is worth 5.7. Okay, so now we have found all three angles and all three sides using law of sines and some geometry, and this one is all done. So that is your introduction to the law of sines. Problem example 1 was 2 known angles and only one side, and problem number 2 was only 1 known angle and 2 known sides. So there's your 2 examples you can reference back to, and that'll do it. So let me give you just a brief overview of what your assignment looks like, and then you can end this video if you'd like. Your assignment today, my Algebra 2 students, is Continuity Learning Plan assignment number 7, Law of Sines. You have 4 problems here where it says solve the triangle, which means that you need to find all 3 angles and all 3 sides, just as I chronicled in the prior 2 examples. You can print this if you have a printer. If not, you can write it out, sketch it out by hand, and show your work just like I did before I made this video. And take a picture of it and upload it to Google Classroom as you are familiar, and you will be all set. So please, just these 4 problems to the best of your ability in a likewise fashion as I did in the notes. So if you're all set with that, I'll see you later. Have a great day. Good luck. However, I will show you where the law of sines formula comes from if you'd like. So if you're so inclined, stay tuned. If not, I'll see you down the road. All right, the purple triangle here is an oblique triangle. There's no right angle in the purple triangle, but what I've done here is I have dropped an altitude, which is this line from A down to the base of the triangle, this altitude here. When you drop an altitude, you get right angles at the bottom. So now I have this light blue triangle, which I could call triangle 1. The light blue triangle is a right triangle. And this light yellow triangle, which I could call triangle 2, is also a right triangle. So there's 2 right triangles contained in the oblique triangle. That's a key to deriving this formula. Okay, so how it works is the following. If I look at the sine from angle B, which I'll grab right here, the sine from angle B, now I'm just looking at the light blue triangle, the sine is the opposite, which is H, over the hypotenuse, which is C. All right, and then if I abandon the blue triangle for a moment and look at the yellow triangle, if I start at angle C, the sine from angle C would be the opposite, which is H, over the hypotenuse of the yellow triangle, which is B. Okay? Next, if I eliminate the denominators, what I would have to do is the following. To undo this divide by C, I'd multiply both sides by C. So then I would have C times sine B equals H. Okay? And then in the other equation here, to undo dividing by B, I'd multiply both sides by B. So I'd have B times sine C equals H. Now, notice that they both equal H. In this equation, H is equal to C sine B. In this equation, H is equal to B sine C. So since they're equal to each other, you can set them equal. So it's fair to say that C sine B is equal to B sine C. All right? Finally, if we divide both sides by sine B times sine C, if we do that to both sides, and it's getting late, my handwriting is getting worse and worse. I apologize. Maybe in another life I'll have good handwriting. We divide both sides by sine B times sine C. Watch what happens. We have sine B over sine B on the left side of the equation. Those cancel. So we're left with C over sine of angle C equals, and on the right side of the equation, the sine C's cancel out. So you have side B over the sine of angle B. Thus, you have the law of sines. So that's where it comes from, my friends, dropping the altitude inside of the oblique triangle. And it does work, and it is wonderful for finding missing angles and sides of oblique triangles. So if you've stuck on with me this far, you're my all-star student. Thank you so much for watching this HansenMath video, and good luck with this lesson and all of your mathematical studies. Have a great day.